All right, guys, so in activity 9-2, we're going to be using the quadratic formula. So we're going to solve quadratic equations using this formula. So we are going to start on page 141. Let's go ahead and get started. You will probably want a calculator today also, just so you know. All right, so the quadratic formula is this formula here that's in this yellow box, where we solve for x by taking the opposite of the b term plus or minus square root of b squared minus 4ac and put that all over 2 times a. Now the a, b, and the c that I'm getting from this formula come from the coefficients in our problem, which is in standard form. So the ax squared plus bx plus c equal to 0. And again, this one we have to have it equal to 0 before we can put it into our quadratic formula, because the signs of our numbers do matter. Now in your book, we're going to skip number 1. We're not going to really derive this problem. So I actually just want to jump to number 2. The directions normally said to solve by completing the square, but instead I'm going to use the quadratic formula, which I'm going to rewrite for us so we can reference it. So make sure you have this written down somewhere so you can use it later on. But if I have this equation, 2x squared minus 5x plus 3 is equal to 0, that's already in standard form. So what I'm going to do is just pull out what my a value, what my b value is, and what my c value is. Okay, so in the problem, the a is the leading term. So here my a would be 2. My b term, keep the sign with it, so that's negative 5. And my c term is 3. So now we're just going to put it into the quadratic formula. So when it says negative b, I always think of that as the opposite of b. So if b is negative 5, we're going to use positive 5 in our formula. Plus or minus b squared. So this would be negative 5 squared. So I always do this in my head. So 5 squared, that's 25. 25 minus 4 times the a term times the c term all over 2a. So 2 times 2. Okay. Now, what I would suggest doing, again, the 25 came from taking negative 5 and squaring it. Negative 5 times negative 5 is positive 25. For the rest of this, though, I would do that math under the radical. I would just use a calculator. So I'm going to show you how to type it in. So 25 minus 4 times 2 times 3. And the calculator will do all the work for me. So if I hit enter, I get 1 from that. So right now we have 5 plus or minus the square root of 1 all over 4. But what's the square root of 1? That's just 1, right? So we have 5 plus or minus 1 all over 4. So remember, for quadratic equations, we usually have 2 answers. So I'm going to show you how we're going to get our 2 answers out of this. So pay attention to what I'm saying. So the first answer you get is if we took 5 plus 1 and put it over 4. So 5 plus 1 is 6. But 6 over 4 reduces. That answer would be 3/2. There's one solution for x. The other one we would get is by taking 5 minus 1 and putting it over 4. Well, 5 minus 1 is 4. So 4 over 4, the answer would be 1. So here's our 2 solutions, 3/2 and a 1. So the reason I set this up in 2 parts is because of that plus or minus. We have plus 1 and 5 minus 1. So that is quadratic formula. Now, since this one worked out nice with a perfect square, this tells me that this problem could be factored if you wanted it to, but quadratic formula is just another option for you. The nice thing about quadratic formula is it works every time on any problem. You can always use quadratic formula. So when in doubt, you could always use that one. Okay. Your book doesn't really give us any other examples to do, so I just grabbed a couple extra examples so you can write these down somewhere on a scratch piece of paper or somewhere in your book. But let's do number 1 here. Again, I'm just going to rewrite our quadratic formula on top. Okay, so this first one, x squared plus 2x minus 1. We have a couple little imaginary coefficients here. So we have 1, so 1x squared plus 2x minus 1. So when we're finding our a, b, and c term, right, for this one, number 1, my a term, b1, my b term is 2, and my c term is a -1. Again, make sure those signs carry over to the problem. But plugging those into the quadratic formula, then we have the opposite of the b term, plus or minus, and then we're going to do b squared. So do this part in your head. The less you have to type in your calculator, the better. But b squared, so 2 squared is 4 minus 4 times a times c. All over 2a. So 2 times 1. Okay, so that part under the radical I'm going to do in my calculator and save myself some steps here. So let's see, we had 4 minus 4 times 1 times -1. Hit enter, and look at that, we got 8. So right now we have -2 plus or minus the square root of 8 all over 2. Okay, so 8 is not a perfect square, but let's check. Can we simplify the square root of 8? I think we can. So 8, we can split that up into 2 numbers, 4 and 2. We went over reducing radicals already, but 4 and 2, we could split that up. 4 is a nice perfect square that I could square root here. So this turns into -2 plus or minus 2, because the square root of 4 is 2, so 2 root 2 all over 2. So now technically this can get simplified one step further here. If you notice, we have all these factors of 2 in each part. So we can divide this all out by 2, and we'll get our final answer here, which is -1 plus or minus 1 root 2. We could put this all over 1, just so you can see it, but usually when something's divided by 1, we don't need to write it. So here is our final answer. Okay. All right, let's try one more, number 2, where we have 5n squared plus 6n is equal to -5. So a little problem here. We need to make this equal to 0. I'm just going to rewrite this, 5n squared plus 6n. I'm going to add the 5 to this left side to make my equation equal to 0. And it must be equal to 0 before I start doing the quadratic formula. Okay, so now if I look at this, my a term is 5, my b term is 6, and my c term is also 5. So let's plug and chug, put it into our quadratic formula here. So you have the opposite of our b term, so -6 plus or minus square root. So it's the b squared. So b in here is 6. 6 squared is 36. And you can use your calculator for that also. I just figure if I can do it in my head, that saves me a step. But so now we have 4 times a times c all over 2a. So all over 2 times 5. Okay, so now we just have to simplify this down and we're done. So I'm going to use my calculator. Plug that in. So we have 36 minus 4 times 5 times 5. Okay, so I got -64. So it's -6 plus or minus square root of -64 all over 2 times 5 is 10. Now, 64 is a perfect square, but remember, if we have a negative under our radical, that means we have imaginary solutions. Imaginary. So that means we're going to take the I out when we do our square root. So again, because we have a nice perfect square, it won't be too bad, but this would give me negative 6 plus or minus 64. The square root of 64 is 8. But again, because it's negative, let's make it 8i all over 10. Now on my numerator, I cannot add or subtract a real number with an imaginary number. So we're not going to really do anything with that, but we can reduce all of these. We notice we have a 6, an 8, and a 10. Those are all divisible by 2, right? So let's simplify this fraction. So our final answer, we'd get negative 3 plus or minus 4i all over 5. Okay, so that is using quadratic formula. So again, figure out what your A, B, and C terms are. If it helps to write it out on the side, then do it. Plug it into your formula, and then the rest is just simplifying what you get. So if you get a perfect square number, that makes it nice. Then the radical goes away. And then just double check your fraction at the end. Do all 3 parts have a common factor? Because if they do, then you can reduce it. Okay. So we will practice some more quadratic formula tomorrow. But again, the nice thing about quadratic formula is it works for any type of quadratic equation. We can't always factor them. Sometimes they're not factorable. Okay, like number 2 would not be factorable. If I tried to set up an x here and make it factors of 25 that add to 6, nothing works for that. So this is an example where factoring would not be able to be used, but quadratic formula will always work.